So hello everyone, hope you're doing really great and welcome back to our channel. Today we are again having a hard level question in front of us. It's again on the same topic as yesterday. Here also we are going to follow the same backtracking approach and let us see what the question is. It's question 1601, maximum number of achievable transfer requests. So the one thing that I want to tell is that if you have been following my solutions, especially if you have followed my yesterday's video, definitely I'm saying you will be able to code this solution. Though it is a hard problem, you can see here it's written as a hard problem, but definitely I'm sure you can code the solution. It's going to be really easy. See, compared to yesterday, if I talk about this question is going to be really easy. Okay, yesterday we at least had an edge case. We had a hedge case. Because we can't follow all the expansions. There was an edge case to stop at a point so that we don't follow the expansion beyond that. The edge case was there, but today we don't have that. Okay, we don't have that as well. Okay, it's just a full expansion of whatever all possible cases, right? So this is also probably exactly same with that of yesterday. We are also going to follow the backtracking approach here. Okay. So yeah, friends, that was what I wanted to give you the heads up. And another thing is, if you haven't followed my video today, you will see what we have learned, what we have achieved. Okay. With this question, definitely, if you have followed yesterday's video, and if you have been doing coding for at least some months till now, okay, definitely you will be able to solve this question. And remember, solving a hard question in Leetcode is considered as a big achievement. Okay. Now coming to today's question, it's question 1601, maximum number of achievable transfer requests. Okay. So, see, you can go through the questions. I will also go to that, but let me give you a heads up like what we are talking about, right? See, n refers to, as you can see in the diagram, there are some buildings. Okay, the buildings are numbered from 0 to n-1. Okay, so this n is given to us. Okay, if n is 5, right? So it means there are buildings from 0 to 4. Okay, 0, 1, 2, 3, and 4. Okay, and some requests are given. What it means is that, see, this first request that tells that a employee wants to move from the 0th building to the first building. Okay, and employee wants to move from 0th building to the first building. Okay, this first request tells us, first means the index 1. Okay, this request is index 1, this request is index 0. Okay, so the requested index 1 tells me that this particular employee who made this request wants to move from building 1 to building 0. Okay, building 1 to building 0, similarly like that. Okay, this is the fifth request. Okay, 0, 1, 2, 3, 4, 5, so it's the index 5, right? So it's the fifth request. It tells me that the employee wants to move from building 3 to building 4. Okay, now the only condition here they have given is, okay, we will see that in the question. But the ultimate thing here is the net should be 0. Okay, the net gain or loss for each building should be 0. Okay, then only in this thing is possible. Okay, we'll see that. Okay, we have n buildings, number 0 to n-1. Each building has a number of employees. Okay, it's a transfer season, and some employees want to change the building they reside in. Okay, so you are given an arrays request where request of I is equal to from of I and to of I. Okay, represent employees request to transfer from building from I to building to I. Okay, so this is the from building and this is the to building. Okay, all buildings are full, so a list of requests is achievable. Please pay attention here, this is the most important part of the question. Okay, all buildings are full, so a list of requests is achievable only if for each building the net change in employee transfers is 0. What it means is, please pay attention here. Let us take building 0. Okay, so this employee is going from building 0, this employee is going from building 0. Okay, only two employees are going from building 0. Okay, so two employees are going from building 0. Okay, now let us try to find out how many employees are coming to building 0. Okay, this employee is coming to building 0, this employee is coming to building 0, again 2. So two employees are going, two employees are coming. That means this requests are achievable from the standpoint of building 0. Okay, that's what they're trying to say. Okay, all buildings are full, so a list of requests is achievable only if for each building the net change in employee transfers is 0. That means if two employees are going, two employees should come back. If single employee is going, single employee should come back. If they are not coming back, then that request cannot be achieved. Okay, as simple as that. So for example, see, A wants to move to building 0, B wants to move out of building 0. Okay, if that is so, what happens is, if the number of intakes in building 0 is not equal to number of outtakes in building 0, then all of those requests will be cancelled, as simple as that. Okay, that's the basic idea. This means the number of employees leaving is equal to number of employees moving in. Okay, for example, if n equal to 3 and 2 so they have given example here. Okay, so you can go through that example. Okay, it's exactly what I have told you. You can just go through it, it's given in theory, you can just go through it. So let's come to the actual question now. Return the maximum number of achievable requests. Okay, out of this how many requests can we achieve is the question. Okay, so if we see this example one. Okay, so as I mentioned, from a building 0 standpoint, it's clear, right? Building 0. Okay, one employee is going out, so yeah, one employee is going out. Second employee is going, so only two employees are going out. Similarly, for building zero, two employees are coming back also. So building zero standpoint, everything is clear. Now come to building one standpoint. Okay, this employee, okay, first of all, how many are moving out? From building one, this employee is moving out. From building one, this employee is moving out. Okay, and coming to how many employees are getting in? This employee is getting in. This employee is getting in. Okay, so two employees are going out. Two employees are coming in also. Okay, this also fine. Okay, building one also over. Now coming to building two. See, building two, how many are going out? See, only a single employee is going out and only single employee is coming in, so that's fine. Now coming to building three. Building three, a single employee is going out, but no employee is coming in. Okay, so this request cannot be accepted. This request cannot be accepted. Now coming to building four, a single employee wants to come in, but there is no employee going out. So again, this request cannot be accepted. Okay, that means out of these six, okay, out of these six, only five can be accepted, which are these. Okay, only these five can be accepted. Building three and four, there is a conflict because an employee from building three wants to go to building four, but no employee of building four wants to move out. So building four is already full. Okay, so a new employee wants to come there, but as it is full and no employee is leaving, that's why there is no vacancy. You cannot, settle a new employee there. That's why this move is not possible. This request has to be cancelled. So the total number of that is what the question is, right? Maximum number of achievable requests. Okay, in this case, going to be five. Okay. So by now, I think we would have definitely made your mind that this question is going to be very, 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 very hard. And why, I told so much of things in the starting. But let me tell you, it's going to be very easy because we have till now not seen the most interesting part. Let's see that now. Okay. So this is the most interesting part. Here they've clearly mentioned that the request line is going to be 16. Okay. And yeah, these things are not important, but this is the most important part. Request length is going to be till one between 1 to 16. Okay, so if we consider it to the max, that is a 16, we'll have at most 16 requests only. Okay, 16 requests only. Now consider this in the raw way. If I do the brute force approach, if I do the real expansion, what will happen is that, so when I say real expansion, I told you a diagram straight, right? So each case, for example, in the first case, what we are choosing, with that decision, if we move and all the possible cases we try, what will be that? So this is expansion tree, right? So now let us talk about this. I have 16 requests, okay, at max. Each request I will have two options, okay. Either it can be selected, it can be granted, or it should not be granted, okay. There are two options. So if I try to do it in that way, so there will be total 2 raised to power 16 cases. Okay, it's definitely achievable. Okay, 2 raised to power 16 is definitely achievable. It's around, I think, so somewhere around it will be 64,000 something. It's definitely achievable. It's not a very big thing to do practically. Okay, so definitely it's achievable. It's, see, 64,000 something within integer. It can be stored. Those numbers can be stored within integer. That's one more important part. See, these are some of the hints I'm giving you, because if you talk about bit manipulation, which is something advanced, okay, these things will be important for you, because in a bit, how many, so sorry, not in a bit, in an integer, how many bits are there, whether I will be able to come out of them or not. So these things are some of the decisions which you'll have to make. Okay, I'm not discussing bit manipulation here. It's somewhat advanced topic. In this question, also can apply that, but in this question, I will try to solve it using the backtracking approach. Okay, so 2 power, sorry, yeah, 2 raised to power 16 is not a big thing, and we are going to follow the brute force approach, going for all the possible cases and then going to find the solution. That's what we are going to do. So this was the hint for it. Okay, if you have seen this function will not be hard anymore. Okay, and if you have seen my yesterday's video, and if you are able to catch this hint, I think you can definitely go to the solution within the next 5 minutes. Please try it on your own once, or please go through yesterday's video and then try it on your own, because I want you to enjoy that sense of pride which you will get after solving a hard question on your own. Okay, so now let's come to the solution. Please see yesterday's video and try it out on your own once. Then please see the solution. So I am expecting you to pause the video by now. Okay. I am going to continue from the solution from now onwards. So if you would have tried now, let's see that what the answer is going to be. Okay. So this is the final answer which I'm going to return. Okay. This will be my final answer. First, I'm taking the length of the request. Okay. See, the maximum length of the request is going to be 16. Okay. Please have that in mind. Okay. I will just write it here. The max length is going to be 16. Okay, it can't be more than that. This is the function through which I'm going to implement the changes. I've already mentioned it's going to be a backtracking solution. Okay, this is the initial function call. Okay, the first function call. So let me tell you what are these things and what it doesn't mean. Okay, first this thing is the index. Okay, index means, see, for example, there are some m requests here. Okay, there are some m requests here. Okay, now I will go through each one of them. Okay, I will start from the zeroth one. I will go through each one of them. Okay, so for each one of them, there will be two options: either to accept it or to reject it. Okay, I will try out both options. Okay, I will make a recursive call to the same function after updating the changes for both the cases. Okay, and ultimately, when we reach the that means, see, there are, suppose I'm okay. So when I reach the end of the loop, end of the I will process all the requests for any one case. Then I will try to find the answer. Then I will record the answer. That's what I'm going to do. Okay. So this index will tell me which current request I'm processing. Okay. So for example, index 0 means I will be processing the 0 request first. Okay. If index is 1, that means I'm processing the 1 request. That's what about it. Okay. Initially we'll start with index of 0, as I mentioned clearly. Okay. Then there comes the request granted. Okay. Request granted means, for example, suppose I have granted this request. Okay. Then I'm going to the next index and I'm granting this also. So the current value of request granted will be 2. Okay, how many requests till now we have granted? This is, this actually is going to contribute for the answer. Remember that. Okay. Now coming to the net count of buildings. Okay, so this array, this is basically array, as you can see here. This is going to be the length of n. Okay, what is n? Basically, n refers to the number of buildings which we have. Okay, 0 to 4. Okay, 0 to n minus 1. So this will tell me the count of, that is net count of each building. Okay, initially all of them will be 0, as we know that. Okay, net count I'm making initially as 0. When suppose employee moves to a building 1, so the net count of building 1 will be equal to 1. Okay, if employee is removed from building 1, then the net count will become, subtract 1 from whatever count is there. Okay, suppose the employee moved to building 1, it will have plus 1. If some other employee moved out of building 1, then it will become 1 minus 1, which is 0. Okay, it will become 0 again. Okay, so at last, that's what I'm checking. If see, I will try out all possibilities. When I reach the end, I will check if the net count, okay, if that is all the indices in this value. Okay, sorry, all the values in this, all the indices of this array are 0. If it is 0, then it's going to be a valid solution. In that case, this particular thing is going to be the answer. Okay, such answers we have to collect, and the max of such answers is going to be my answer. Okay, I will again repeat. See, this net count of buildings will tell me. See, it is an array first of all. Okay, it has n values. Okay, each value, for example, zeroth value of this array tells me the net count of zeroth building. Okay, first value of this array tell me the first, that is the net count of the first building. Okay, at that instant. Okay, at this particular index. Okay, suppose I process 3 values, so it will tell me, so based on this, what are the net count of buildings at this stage? Okay, at this stage. Similarly, when I have processed all of these, okay, when I process all of these, I will check. That's what I'm checking here. Basically, see, I will check if the all the values in this net count of buildings is 0. If it is 0, okay, that's what I'm checking here. Count of 0 is equal to 0 n. What is n? And it's basically its own length. Okay, if it's equal to n, that is all values in that as 0. What I will do is, this will be a valid answer now. Okay, this thing will be a valid answer now. Okay, this valid answer, I'm just trying to compare with my other answers. Whichever is the max, I'm going to update it to my answer very well. Okay, this final answer will be written here. Okay, this was the ending condition. Okay, this was the ending condition, but we'll see the other things now. Okay, so there are always two cases, as I mentioned. First case is if we are accepting the ith request. Okay, we are accepting the ith request. Okay, the other case is we are not going to accept the ith request. Okay, we're not going to accept the ith request. Okay, see, ith basically means, see, ith means index. Okay, ith means index. Okay, index request. Okay, you can just write it in that also. You could have also made it I could have made it I basically, but yeah, fine. I've written index there. Okay, so basically ith means basically this index. Okay, this index. Okay, so now coming to the first case where we accepting the ith change, accepting the ith request. So what will happen now? See, in the net count of buildings. Okay, I will go to this index. Okay, see, I will go to zeroth index of the net count of buildings and I will add 1 to that. Then I will go to first index of the net count of buildings and I will remove 1 from that. Okay, that's what I'm doing. Okay, how to get this 0? See, what is this 0 first of all? How it's coming? First, we have to go to request of 0. See, this is inside this element, right? This is the 0th element. Come to 0th element. Inside that, take again the 0th element. Okay, that's what we're doing here. Okay, request index of, see, this is the index element, right? See, index initially 0, right? This is the index element. Okay, this is the index element. Okay, because why? Because the index is 0 initially, right? This is the index element. In the inside the index element, see, what I've highlighted now. Okay, what I've highlighted on the screen is basically this part. Okay, this part. Okay, inside that again 2 values are there. That's what we're extracting through this. Okay, so this will tell me this 0 basically tells me that I'm going to select this. Okay, see, after selecting 0 again there is a 1, right? That 1 will come from this. Okay, yeah, so for the 0, that means this 0 basically tells me from. Okay, so I am moving this employee from the 0th building, so it is a minus will come here because it is being removed from the 0th building and it's being added to the first building. That's why in the one, that is this one, that is the first index of that, we are going to add it, so plus will come here. Okay, we're adding it. Okay, then I'm going to call the recursive function so that it moves to the other cases also, other indices also. What I'm doing, Please pay attention. I'm doing index plus one. Okay, move to the next index now. That's what I'm going trying to give a hint. Okay, because the request is accepted, so request granted plus one. Okay, the value is added by one and it's passed. Okay, and the same we have made change to the net count of buildings, right? The same array is passed. Okay, after it is passed, okay, it will go on. Okay, it's a recursive call, right? It will go to a next stage. It will go another layer of a stack, right? It will be going on. Okay, stopping condition, as I already mentioned, the stopping conditions. Okay, if index equal to m, what is m? M is basically the length of request. Okay, so I processed for all these m requests, and now I am at the index m. Okay, so remember array is between 0 to m minus 1, right? So I have processed all the requests and I am at a on a exceeding index now, which is m. Okay, what I will do is I will just check if all the values in the net count of building is 0. If it is 0, then I will this will be a valid answer then. Okay, so I will just try to compare it with my previous answers. We are going to take the max out of it. Okay, and then we are going to return condition. Okay, so for this index we will not count all these things. Okay, these things will not be executed. Okay, I'm just returning it. Okay, this is the base condition. So I explained till this now. Okay, so see, I've made some changes to this now. Okay, I made some changes. Now we will be canceling those changes. Okay, I will be canceling those changes. Okay, so here see the same thing minus came, right? Now for the same thing plus will come. Okay, now for the same thing plus came, right? I'm going to subtract. I'm going to minus will come for the same thing. What it means is I'm going to subtract those changes. Okay, that's what is. See, this is the backtracking step basically. Okay, what we're doing is we are going to backtrack the changes and then we are going to see the next possible solution. Okay, that's what we're doing. Okay, so as I mentioned, this is just the first case only. Okay, this is the first case. The other case is that I am not going to accept the ith request. So what will happen? I will just simply go to index plus one. Okay, I will not update grant request granted. This will remain the same as the previous iteration, and this also will remain the same as the previous iteration. Okay, so this is what is the case when we are not going to accept the request. Okay, so both the cases, see, it's like a recursive call, right? See, these are dynamic related solutions. You will understand this out of your own experience only. But one thing I want to tell you, see, if you trace this example with my code, what will happen is that, see, I should accept all these requests and I should deny this request. Okay. I should accept all these requests and I should deny this request. If I deny this request, then if you see the net count of buildings array, what will happen is for building 0, 1, 2, so it will be definitely, net will come 0 as we have seen previously. For building 3 and 4, it will come 0 only if I do not accept this request. Okay, so what will happen is for building 0, 1, and 2, as we already saw that it's anyway going to come 0, but for building 3 and 4 also it will come 0 if I do not accept this request. In that case, I will come to this edge case again. Okay, okay, in this edge case will come. Okay, then in that case, this request granted will be 5. Okay, why? Because we have accepted this 5 request. Okay, this 5 request we have accepted, so answer will be updated here. Okay, and finally we'll return it. Okay, we'll try the other cases and finally we'll return that as the answer. So that is the basic idea, friends. So this was a backtracking solution, and this, if you the interviewer asks you to show which exact statement is contributing for the backtracking, you have to show this statement. Okay, this is the one which is going to contribute for the backtracking because we are backtracking. Backtracking means basically we have moved a step forward. Now we are going to come back again to the same state. Okay, this is what we are doing here. We are canceling the changes and we are coming back to the same state. Okay, so that we can execute the other possible cases. Okay, so after that was all. I will quickly run and show you this. So as you can see, it's creating the test cases. Okay, it's nearly 80% faster. Okay. So yeah, that was all. I will give you the solution in the description of the video. Please go and check it out. And if you have lost, please do comment below. But see, please see, take some pride in doing what you are. See, coding is not something which we will get if you study overnight, right? Please take some pride in doing what we are getting. Please comment, and if you have any doubts, please do get it clarified. Okay. See, why I do all these things, why these videos are important. But see, if you solve on your own without any a background or a group, you will never be able to continue for a long time. Okay. You need a interactive group or same people of same interest. Okay. Then only you can continue further. So that's what my idea is. Please utilize the resources available in the internet, in the YouTube, and please make something best out of your career. Right. That's what I wanted to convey. See you tomorrow. Thanks a lot.